But pause for a sec. God, give me the courage to change the things I can, pollution and technology. Accept the things I cannot change, climate change. Serenity and wisdom to know the difference. Dr. Ritesh, Arya's prayer on climate change. In the remote and majestic land of Ladakh, where the rugged peaks of the Himalayas kiss the sky, a remarkable story unfolds. This is the story of Dr. Ritesh Arya, a geologist who holds the Guinness World Record for his groundbreaking work in providing groundwater solutions for the Indian Army. One day, while drilling a bore well for the Indian Army along the banks of the Indus River, Dr. Arya stumbled upon a newspaper article that would change his life's course. The article discussed a UN report on man-made global warming. For Dr. Arya, this was a shock.
I couldn't believe what I was reading. Climate change, comprising global warming and cooling, is a natural cyclic process, like day and night. The warming phase acts as a transporting agency in nature, moving materials deposited during global cooling times. But this was a belief. Science works on evidence. And so, Dr. Arya embarked on a quest to gather the evidence needed to support the natural cyclicity of climate change.
The first piece of evidence came from the borehole samples. Initially, the borehole site yielded samples that corresponded to those derived from the Ladakh batholith and Stock Kangri range. After 15 meters, the dominance of these two litho units decreased, and the borewell samples revealed different lithology with traces of the ancient Indus Glacier, indicating significant past glacial activity. This marked the beginning of a new phase.
Discovering evidence of the Indus Glacier was a crucial first step. It showed that glaciers had existed and receded long before industrialization.
This provides a valuable baseline. Dr. Arya gazed at the Kardungla mountain ranges, the highest motorable road in the world, as the probable source of the borewell samples. The glacier today is limited to the peaks of the Himalayas.
Borehole samples indicated the extension of the Kardungla and Stock Kangri glaciers at the drilling site, assisting in calculating the length of the retreating Stock Kangri and Kardungla glaciers. Kardungla Glacier had receded 24.5 kilometers since the last ice age around 11714 years from today.
Having established the existence of the Indus Glacier and its recede much before industrialization, Arya was on a mission to uncover more evidences to understand the cyclicity of these processes. High in the northwestern Himalayas lies the Ladakh batholith, a granite expanse preserving a record of climate cycles spanning millennia. These granites formed below the surface of the Earth are uplifted due to tectonic activity. These are resistant to weathering and reveal intricate patterns of climate fluctuations over time.
The Ladakh batholith serves as a natural archive, preserving evidence of climate cycles from the onset of precipitation in the form of snow and glacier formation. This also suggests that the Himalayas underwent uplift during global cooling periods.
In the Ladakh batholith, Dr. Arya discovered a series of C-shaped patterns etched into the granite. These Arya's C cycles provide a visual testament to the cyclic nature of Earth's climate.
These cycles are not merely visual oddities. They represent a complex language of climate change, unveiling the natural cyclical patterns of warming and cooling periods. The C-shaped formation has been carved by action of climate change. The protrusion was caused by minimal erosion during global cooling periods, and a central depression was carved by water action during warm periods.
Arya observed these features for a long time, and eventually they began to tell a story. These formations serve as visual evidence of the cyclical nature of Earth's climate, imprinted on the Ladakh batholith.
The Arya C cycles reveal a fascinating symmetry in Earth's climate system. The top of the letter C represents ice ages. The curve shows gradual warming. The center indicates warming maxima, and the lower curve represents cooling leading back to an ice age. This pattern impacts ecosystems significantly, with more water leading to proliferation and massive flooding, while cooling results in freezing and extinctions.
The consistent thickness of these cycles is of significant geological, geomorphological, and taphonomic interest. Deciphering the language of climate, Dr. Arya discovered 10 such cycles, After every 4 cycles, there is a half cycle, considering the last ice age to be of 11714 from present. Each cycle come to be around 1338 years and half cycle around 669 years. These cycles reveal the transformation from ice ages to warming maxima and back, following a curvilinear path.
Understanding these cycles is crucial. They help us see the larger picture of climate change and its natural rhythms.
Lamayuru Monastery was constructed in 1006, coinciding with the outburst of Lamayuru Lake. The landscape, resembling the surface of the moon on Earth, is the result of paleoglacial sediments.
Evidence of extinct glaciers approximately 1,006 years old is seen, showing that the majority of the glaciers in Himalayas were extinct or on the verge of extinction much before industrialization.
The Himalayas, often referred to as the water tower of Asia, are a vital freshwater source for billions. Climate change accelerates glacial melt, leading to flooding and soil enrichment, but also increased sea levels. Reduced glacial mass will eventually impact agriculture and water security.
Glacial melt provides water for billions, but reduced glacial mass will have long-term consequences. We must adapt to these changes with both traditional knowledge and modern science.
Warming maxima correspond to peak temperatures and maximum glacial retreat, resulting in reduced glacial mass and volume. This impacts water availability and power production from hydel power projects, which are thus non-renewable energy sources. The shrinking lakes of Ladakh, a visible consequence of a changing climate. Recent studies have revealed a concerning trend. Leh was once known as the City of Lakes, with evidence of paleo-lakes in Spituk and Shea. However, many of Ladakh's lakes are now shrinking due to reduced glacial meltwater input. For instance, Somariri Lake has decreased by around 1 meter over 1,000 years. That means about 8 meters in the last 11714 years from present. This shrinkage is primarily driven by a decrease in glacial meltwater input. Rivers reshape. The rivers of the Himalayas, shaped by glaciers, are dynamic forces influenced by climate, geology, and time. For instance, the Pangong River was once a tributary of the Shyok River, but is now a lake due to decreased glacial melt. The Saraswati River, once mighty, is now history, but its paleochannels remain, helping us understand the long-term impacts of climate change. As the warming increases, the glaciers melt and the water from the glacial melt will decrease in the long run. As the discharge decreases, the raw material for power plants, i.e. water from the glacial melt, will decrease. This will adversely affect the power production in the hydel power projects. Hydel power projects are therefore non-renewable energy plants. Echoes of the past, whispers of the future. The Arya's sea cycles remind us that climate change is an intrinsic rhythm of our planet. Understanding these rhythms helps us anticipate future challenges and develop sustainable strategies.
By recognizing the natural cycles of climate change, we can prepare for the future with greater insight and wisdom. Understanding these rhythms helps us anticipate future challenges and develop sustainable strategies.
Adapting to the rhythms, sustainable strategies for a changing Himalaya. The Himalayas, a region of breathtaking beauty and cultural diversity, are on the front lines of climate change. Adapting to climate change in the Himalayas requires a multifaceted approach, drawing on traditional knowledge and modern science. Addressing these challenges requires global cooperation and local action. The Himalayas in a changing world. The challenges facing the Himalayas are global issues. They provide essential water to billions. Global warming has decreased the glaciers, and this happened much before the industrialization. UNIPCC report of Holding Man and his activities responsible to increasing global warming temperature is therefore a very misleading statement. As a flash flood or cyclone may affect entire communities, people will be busy finding solutions to reduce temperatures. The melting of glaciers due to global warming has had far-reaching consequences, from flash flooding to sea level rise. The challenge now extends to the Arctic, Antarctic, and various other regions. The global cooling may be witnessed around 2300 as per Arya cycles. Addressing these challenges requires global cooperation and local action. The Arya sea cycles offer a unique opportunity to predict future climate trends. Applying mathematical models derived from these cycles, we can anticipate future climate fluctuations and plan accordingly. Triple dots. By applying the mathematical models derived from these cycles, we can make predictions about the timing and magnitude of future climate fluctuations. Echoes of the past, whispers of the future. This is the story of Earth's climate revealed through the eyes of a geologist. Enjoy global warming, it's natural. A Tethys Museum Foundation production.